Okay, so we're starting Unit 6, Module 12.1, and Arithmetic Sequences. So we're looking at patterns. So hopefully you can see this and enlarge it. Definition of a sequence is an ordered list of numbers. Arithmetic sequence is also known as a discrete linear function. And it's a sequence where consecutive terms have a common difference. So if we look here, we're adding 5 each time. And on this example, we're adding 2 each time. So that number that you're adding each time has to be the same. We use 2 rules when we describe arithmetic sequences. We use an explicit rule, which puts it in terms of finding a common difference. It allows you to find the nth term, further terms out. We also talk of a recursive rule, which defines the sequence in terms of the previous. So you have to keep adding each time. These are the 2 formulas we're going to look at. Make sure you have them written down because they are going to be your little lifelines. So we're going to use the given table to find an explicit and recursive rule for each sequence. So the first thing we have to do for everything is find the common difference. So we look at this. What is happening each time? So we take 5 minus 2, that's 3. We go 8 minus 5. Oh, that's also 3. 11 minus 8, that's 3. 14 minus 11, that's 3. And 17 minus 14 is 3. So our common difference is 3. That's a big, huge part of being able to find an arithmetic formula. So we go to our recursive. Notice, this is the previous term. We don't know what that is. So on a recursive, it's extremely important that we say f of 0 is equal to 2. That tells us where our pattern's starting and what values we're starting with first. Then we simply say f sub n, this is a formula we're writing, is whatever the previous term was plus our common difference of 3. That's the formula. That's it. For the explicit, we're going to follow this pattern. So it says f sub n, and we don't have to know what the first term is on an explicit, only on the recursive. We take our first term, which is 2, plus our common difference of 3 times n minus 1. Since we don't know what term we're looking for and we're only writing a formula, we should have n in there. We're going to distribute that 3 and combine like terms. So we get f sub n equals 3n minus 1, there's our formula. So we're going to look at this one. And we have this table up here, so our common difference. Again, we got to go, okay, negative 7 minus, let me go the other way. Negative 2 minus negative 7. Be careful you double negatives because that is 5. And then if we go 3 minus negative 2, that's also 5. 8 minus 3, 5. 13 minus 8, 5. 18 minus 13, 5. Common difference is 5. We're going to our recursive formula. We're going up here. The only thing we're plugging on a recursive is D. We're going to actually state what the first term is. So f sub 0 equals negative 7. It's telling the person where the pattern starts. And then we have f sub n equals f sub n minus 1, whatever the previous term happened to be, plus 5. Now, we could add a negative. That does happen, so it would just be minus instead of a plus. Explicit formula, f sub n equals our first term, which in this case is negative 7, plus our common difference of 5 times n minus 1. Cleaning that up, that's negative 7 plus 5n minus 5. So our formula is f sub n equals 5n minus 12. And there we go. So we're going to go back over on this side, and we're going to work backwards just a little bit. And we're going to write the terms given the sequence. Here's our formula, and we're going to actually create the sequence. All this means is we're going to plug 0 in for n. So our n value starts at 0 because they tell me the values to use. So that means negative 1 plus 2 times 0, well, that's just negative 1. For 1, I plug it in, I get negative 1 plus 2 times 1. That's 2 plus minus 1 is 1. Plug in 2. We get negative 1 plus 2 times 2, which is 3. Plug in the value of 3. We get negative 1 plus 2 times 3. That's going to be 5. And when we plug in 4, we get negative 1 plus 2 times 4 equals 7. Notice, they're odd values. This tells us what ones to use, so we write our sequence out. That's -1, 1, 3, 5, 7, and it continues. Here, we're going to graph it. All the graphs of arithmetic should be linear, so they should look like a line. So 0, -1 is here. We're at 1, 1 here. We're at 2, 3. 3 should be up at 5, and 4 should be up at 7. If you look at this, and I know my dots aren't quite lined up perfectly, but it makes a line when we graph it. Okay, so we have another one we're going to look at on the other side. Arithmetic sequences and geometric sequences can be a lot of fun. This one, we start with the first term is 4, so they tell us n sub 1 is 4. They want us to find the values greater than or equal to 2. Okay, so we're not really going to be using this one. It was given to us. I don't want to put the negatives there. I'll circle it. So we want 2, 3, 4, 5, because it doesn't tell us where to stop, so we're going to do a few of them. So that means I'm going to take the previous term, and that's why I have this one listed. I have to use my previous term and subtract 0.25. So that's 4 minus 0.25, which is 3.75. Then we have to use the 3.75 and subtract 0.25. That's 3.5. And then again, 3.5 minus 0.25. Well, that's 3.25. Notice these aren't changing a whole lot. And then we have 3.25 minus 0.25, which is 3. So on our equation, we have 1, we're up at 4, 2, we're up at 3.75, 3, we're at 3.5, 4, we're getting closer to 3, and at 5, we are at 3. And I know mine looks like it might be, doesn't cross at 4, and it looks like it might be kind of diagonal, a little bit bumpy. That's just me graphing on the board. So the last problem we're going to talk about, there's 19 seats in the row nearest the stage of a theater. Each row after the first one has 2 more seats than the row before it. Since it has 2 more seats, our common difference is 2. We're going to use the explicit formula because we want to find the 13th row, and I don't want to do them all out to the 13th. So we simply say, well, the first row has 19. Our common difference is 2. That's 19 plus 2n minus 2. So that's 2n plus 17. That's the formula. Now we're going to take that formula and we're going to plug in 13 for n because we want to know the 13th row. So that's 2 times 13 plus 17. 26 plus 17 gives me a total of 43 seats in that row.